Okay, if you've been anywhere near AI development lately, you already know the landscape is, frankly, kind of a mess right now. You've got raw foundation models dropping seemingly every single week, a dozen different ways to prompt them, and an endless stream of new orchestration tools. It's a lot to process. But today, I promise you clear, actionable answers by the end of this explainer. We're going to completely demystify the two most important tools in the AI engineering space right now, LangChain and LangGraph. We have a really solid roadmap ahead of us today. We're going to logically trace the natural evolution of an AI application by hitting the need for frameworks, LangChain as the linear builder, hitting the complexity wall, LangGraph's state and cycles, an architectural showdown, and finally, choosing the exact right tool for your project. All right, let's jump right into part one, the need for frameworks. Look, raw, large language models, your GPTs, your Claudes, your Geminis, they are undeniably amazing. But building a true production-ready AI system involves so much more than just firing off a prompt and crossing your fingers for a good response. Modern apps require a massive amount of infrastructure to actually function reliably in the real world. You need prompt management to standardize your inputs. You need memory handling so your bot doesn't just forget who it's talking to halfway through a chat. You need tool calling so the AI can search the web or query a database, alongside multi-step reasoning, state persistence, and error recovery. Building all of this from scratch for every single project? Total nightmare. And that is exactly why orchestration frameworks exist in the first place. Which leads us perfectly into section 2, LangChain, the linear builder. Let's look at the first major solution that really brought order to the chaos. So LangChain is an open source framework specifically designed for building applications powered by large language models. And it does this using highly modular components. Actually, the best way to think about it is like a massive box of incredibly well-designed Lego bricks. It provides abstractions that help you connect LLMs with external data, build basic agents, manage memory, and quickly spin up chatbots or basic retrieval augmented generation, or RAG systems. Its entire goal is to drastically reduce the headache and complexity of integrating AI into your software. To really wrap your head around LangChain, think of an assembly line. Its basic workflow is highly sequential and incredibly efficient. You take an input, you format it using a prompt template, you pass it straight to the LLM, and then you parse the output. It's a clean, linear manufacturing belt. Your data moves in exactly one direction, from step 1 through step 4, producing a highly reliable result at the end. And this brilliantly illustrates how that assembly line actually translates into code with LangChain Expression Language, or LCEL. The declarative syntax is beautifully simple. It's literally just chain equals prompt, pipe, model, pipe, parser. It directly mirrors that linear assembly line we just talked about. This makes chaining operations together incredibly clean, easy to compose, and very fast to prototype. But what happens when your application needs to be, well, smarter than a simple assembly line? That brings us to section 3, the complexity wall. This is what developers inevitably face as their applications grow. Let me ask you this. What actually happens when your AI agent gets stuck in an infinite loop? Because if you've ever tried building a genuinely autonomous agent using traditional linear frameworks, you know this exact pain. You're just sitting there, watching the terminal logs, as your agent tries the exact same broken tool over and over and over, completely failing to recover until the whole thing just crashes. The hard reality is, the assembly line breaks down when tasks get complex. Traditional LangChain chains are amazing, don't get me wrong, but they are mostly linear. When you try to build agents that require infinite loops, multi-agent planning, or the ability to gracefully recover from an unexpected API failure, it becomes a nightmare to manage. The framework really struggles with poor state tracking and limited persistent memory. When you need an agent to stop, wait for human approval, and then pick up exactly where it left off, a purely linear chain just isn't built for that. To solve these exact limitations, we enter section 4, LangGraph, state and cycles. This is a massive evolution in AI orchestration. Enter LangGraph. This is a framework for building stateful, multi-agent AI applications using graph-based workflows made up of nodes and edges. We're totally upgrading our analogy here. We're no longer on a linear assembly line. We are now working within a complex corporate web. In this graph-based architecture, each node performs a task, like calling an LLM or a search tool, and the edges define the dynamic transitions between them. This means your agents can actually talk to each other, branch off, and coordinate highly complex tasks. Let's look at the underlying mechanic that makes this all possible. Now, what's really interesting here is the concept of state. State management is LangGraph's absolute superpower. At its core is a state dictionary continuously tracking messages, tools used, and the current step. It acts as a shared memory passed across all nodes in the workflow.
Because this state is persistently tracked, a workflow can literally pause itself, remember exactly what it was doing, and resume much later. It completely prevents data loss if a process crashes and allows multiple agents to seamlessly share information.
And because we have state, we instantly unlock the next superpower, cycles. Unlike linear chains, LangGraph fundamentally changes the game by natively supporting cyclic execution. An agent can think, use a tool, analyze the result, and then loop back to think again based on that brand new information. This iterative reasoning is exactly how humans solve complex problems. And LangGraph allows your AI to do the exact same thing, instead of just moving blindly in a straight line. By combining state and cycles, LangGraph delivers true enterprise-grade features. It supports multi-agent supervisor patterns, where a manager agent dynamically coordinates worker agents. It allows for durable execution, meaning your long-running workflows can actually survive a crash or an API timeout. But honestly, perhaps most importantly, it enables human-in-the-loop approvals. Think about highly regulated industries, finance, legal, healthcare. You absolutely cannot have an AI autonomously executing a massive financial transaction without human oversight. LangGraph can pause the entire workflow, wait for a human to review the state and hit approve, and then instantly resume execution. That is a real game changer. Okay, so we have these two incredible tools. Let's move to Section 5, Architectural Showdown, for a definitive side-by-side comparison. So, the crucial point really boils down to this core architectural difference. LangChain is flow-oriented. It's all about getting your data from input to output as smoothly and efficiently as possible. LangGraph, on the other hand, is state-oriented. It's built entirely around maintaining a persistent memory and dynamically deciding what to do next based on that ever-evolving state. To put it all together, LangGraph isn't a replacement for LangChain. It's an enterprise evolution of it. LangChain uses a simpler linear architecture with basic state management. It has lower complexity and a much easier learning curve. LangGraph gives you a graph-based cyclic workflow with advanced state management, excellent multi-agent support, and high reliability. But of course, all that power comes with a steeper learning curve and a bit more complexity. Let's translate all of this into actionable takeaways in Section 6, Choosing the Right Tool. When should you actually deploy each framework in the real world? LangChain remains the absolute best choice for fast, lightweight development. If you're building simple AI apps, creating standard customer support chatbots, just learning the ropes of AI orchestration, or doing rapid prototyping, start with LangChain. If you just need a basic RAG system to answer questions from your company's PDFs, LangChain's linear workflow is going to get you up and running faster than anything else out there. However, when you finally hit that complexity wall, when your agents absolutely need iterative reasoning, when you require persistent state that can survive a system crash, or when you're building a massive enterprise system that demands human-in-the-loop approvals, LangGraph is your mandatory upgrade. It is built specifically from the ground up for complex, multi-agent collaboration and long-running AI operations. We've seen how AI workflows have evolved from basic linear chains to incredibly dynamic, stateful graphs. The tools are literally more powerful than they have ever been, and they're just sitting